So section 1.6 is about transformations. This is now the third year in a row that you have had a lesson on transformations, usually, likely. So section 1.6 is called graphical transformations. And you might have to excuse me, sorry, I got to readjust this. So, got it all right where I wanted to write. So with transformations, I'm sorry I'm not here to tell you my access life story. We'll get there in a minute though. Okay, so transformations helps us to understand the connections between algebraic equation and its graph. Some affect the shape and the size, and some distort the shape like by stretching or compressing. So there are domain changes and there are range changes. Order matters with combinations of transformations, and if you're using a table, which I'll show you how to do that, you can multiply and divide first and then do adding and subtracting second. So you're going to see this a lot, and I'm going to write these. Mine are going to be in some different colors. So y is equal to, and then I'm going to put all my domain or my range changes in red, so plus or minus a essentially is what I'm going to have right here. And then essentially like what's happening right here is like what your function is. It can be for any of the parent functions that we essentially use. So whatever's going to go, the function would be inside there. So anything that happens inside is going to affect your domain, not your range. So plus or minus x, oh sorry, plus or minus b should go right there. And then you would have your x, and then plus or minus h, and on the outside you'd have plus or minus k. So anything that is in red are the range changes, or that means it affects the y values, and anything that is in blue is going to affect your domain, so it'll be your domain changes, or things that affect, not just changes, things that affect your x values. So the black part is just saying that this can be applied to any of your functions, like any of your parent functions. So this, and I'm kind of, this might get a little messy, I'm going to write it out here. So your positive or negatives are going to, whether it's negative or whatever, this one's going to vertically reflect it or reflect it over the x-axis. So we'll say vertical reflection. And then the plus or minus in front of your x value, if it gets multiplied by your x value at all, that's going to be a horizontal reflection that will reflect it over the y-axis, or you can call those flips. The number that's on the outside of your function, like out in front of it, is going to affect your y values. So they're going to be vertical stretch or compression, depending on if it's bigger or less than 1. Well, in between 0 and 1 or bigger than 1. And that's for A. And then B is kind of going to do a similar thing, except for it's going to be the horizontal and vertical, or horizontal stretch or compression. Then the H and the K, when you're adding or subtracting those values, that's going to be, and this one, the H, which is inside with your X, is going to be horizontal shifts. And K is going to be vertical shifts. I know it's kind of all crammed in there, but I can kind of see what each little part is. So If you're multiplying by something, it's going to stretch or compress it, depending on where it is. It's going to be horizontal or vertical. And then if you're adding or subtracting something, it's going to shift it horizontally or vertically. And if there's negatives out in front of those stretches and compressions, it's going to do a flip somehow. So something to remember, and we'll talk about this, we can talk about it a little more later, is that x's, anything with your x values, anything that is horizontal is going to lie. So we talked about it the last couple of years. We all have exes, whether they're ex-friends or ex-boyfriends or people that lie to us that you are no longer friends with. Those are exes because they're liars. So anything with the x is going to do the opposite of what you would expect it to do. So pretty much what we're going to do is we're going to do a few just examples with these. So you're going to, that parent function graph page that we made last Friday is going to be really useful in starting out with that and then graphing it. So you can always use your calculator to confirm, but you want to know these transformations without a calculator as well. So let's see. Let's just go to a couple examples. So if we're going to, let's do this. I'm just going to give you a function, and you're going to say what the transformation is. So we're going to have a bunch of different parts of this one. So y equals the square root of negative x. Then we'll go, and I'm going to write them all up here, and if you guys want to write them as we go, you can. I'll come back and do them all. So y equals negative absolute value of x. C, we'll do y equals negative 1 over x. And then D, we'll go y equals negative x cubed. Then let's have D, E, y equals 1/2 x cubed. F is going to be the square root of 2x. Sorry, y equals the square root of 2x. G, y equals 2 to the 3x. And H, we'll say y equals the absolute value of x divided by 4. Okay, so we're just going to go through and name what these transformations are, just so you can recognize them from the equation. If you want to plug them in your calculator and graph the parent function and this function, you can kind of see what it is. So this x is inside with the x value, and it's a negative inside, which means it's going to reflect it horizontally. So that's going to be a horizontal reflection or horizontal flip. I'm going to stop this, and you're going to have to start a different video to come up with the rest of them because my class is not going to come. Or maybe I'll start over.